So you may be wondering, before I do any of this, do I have to go off and write lots of complicated hash functions? Thankfully, no. It's probably the case that most of your objects already have perfectly acceptable hash functions for most of the things you want to do. For example, every single class in Java already has a hashcode method. It's part of the base object class. So any classes you define and all the objects you create from those classes already have a default hashcode behavior that returns an integer. And likewise, all Objective-C objects have the hash method. It's part of the NSObject base class. And all .NET objects have getHashcode. All Python objects have a hash method. All Ruby objects have a hash method. Now, usually, the default hash functionality will return an integer that's calculated from the ID or the underlying memory address of that object, meaning you should get a different hash value for every object you call this on. And if you have two separate references pointing to the same actual object, you should still get the same hash, which is what you'd want, because it will be calculated based on that actual object's underlying memory address. So if all you need is a unique hash value for each object, you probably already have that behavior. However, when you're writing your own classes, if you ever redefine what it means for objects of your class to be equal, you should always redefine the hash function too. Let me unpack that statement, and this is just us taking a sidestep away from data structures over into object orientation. When you write a new class, you'll always get some kind of default equality behavior, so you can ask if two objects of that class are equal to each other. Now, usually, this default behavior just looks at the ID or the memory address of the object. Is object A actually the same object as object B? Are they pointing to the same location in memory? If so, they're equal. Otherwise, they're not equal. But in the case where you would rather compare the internal state of two objects, so that you might have two separate objects that are really copies of each other with the same important internal data, and you want those to return true for an equality check, you would typically override your own class's equal method or isEqual method or EQL method, whatever that's called in your language. Now, here's where we start to step back into data structures. If you ever override the equality behavior in your class, you must override the hash behavior, because hash codes are so tied to equality. Now, I said earlier, if you have two objects that you consider equal, they should return the same hash value. Well, let's change that should to a must. They must return the same hash. So if you change what it means for your objects to be equal, you should also change what it means to hash that object. Now, okay, bear in mind I'm talking about custom classes here. If all you're ever putting in your hash tables or dictionaries were string keys with string values, you wouldn't need to worry about this. String objects already have their behavior extended, so if you have two separate string objects, they will still count as equal and return the same hash if they have the same content, even if they're actually separate string objects allocated in different parts of memory. So they shouldn't provide any issues when you use strings in hash tables.